from a human impact is quite fast, because clearly, if you get more water than sustainability would suggest, to recover from this, let's say, overexploitation takes less time with respect to recovering from overexploitation of groundwater. And the reason is that if you stop taking water from the rivers, you quickly get to the original situation. Of course, the environment could have been compromised meanwhile, so it may take some time to restore the ecological environment, but from an hydraulic point of view, from an hydrologic point of view, restoration is very quick. And therefore, you can easily understand that even the environment gets back quite quickly once that, from an hydrological point of view, you have restored your situation. In groundwater, the flow is much slower, recharge time is much higher, and therefore, getting back from a compromised situation is more difficult. On the other hand, groundwater is an excellent source of water because there is a lot of groundwater and usually the quality is fine. In order to understand how groundwater reacts to exploitation, it is essential that you understand how aquifers work. And there is a video in my website which is, I think it is excellent. I'm not sure whether it is in this lecture here or, yeah. I'm not showing it to you now, it takes only 10 minutes, but I just wanted to give you an overview. I think it is, from an educational point of view, it is really easy to follow. It's about 10 minutes, if I will remember. It's easy to follow and clarifies, without going into details, into technical details, how aquifers work. Basically, there are two features of an aquifer that are extremely important for the dynamics of the aquifer itself, which are the porosity. The porosity is the volume of voids that can be filled by water, and the permeability. The permeability is the connection between these voids. So if you have a lot of voids but a reduced permeability, the result is that you get a lot of water stored into the aquifer, but the flow is very slow. Conversely, if you have a high permeability, it means that the flow is quite slow, quite fast into the aquifer, and this is explained here. So basically, the result of this situation is that you have a lot of water that is stored into the aquifers, which is relatively easy to take. You see, this is explaining here the difference between porosity and permeability. And the only thing is, the only big question is, how much is my withdrawal sustainable? To what extent is sustainable? If I take this water, how long does it take to get it back? Because of course, if it takes a long time, okay, I may take the water up to the time where there is no water anymore, and then I have to wait maybe 100 years before getting the aquifer in the original situation. And this is a big question. So, how to solve this question? First, keep into account that usually in the underground you have several aquifers. Aquifers means a body of underground water. You have several of them in different layers. Typically, there is a superficial aquifer, which may be present, may be seasonal, may be present only for some months in the year. It is the one that is typically quickly recharged through infiltration. It is the one that is more easily accessible, because in some cases it's also emerging. it is the one that gets more easily contaminated if there is pollution, if there is soil pollution, and soil pollution may be originated by fertilizers, by cars, by other sources of pollution. When you go deeper in the underground, typically you find other aquifers which may or may not connect with the superficial one. In this case, they are not connected. The superficial one is relatively easy to observe if you have wells. Wells are the holes from which you get water. If you have wells, you look at the level into the well, and this is the level of the superficial aquifer. If you go into the deeper aquifers, you can observe them in the same way, by looking at the level into a well. You see that there is here displayed, there are displayed two different terms, unconfined aquifer, confined aquifer. Let's try to see what is the difference. And in order to understand the difference, we have to make a larger section. So let's suppose that we have a mountain here with some rain and infiltration. Okay, this is infiltration or seepage. And let's suppose that at a certain point we have a rocky layer here. Okay, and then here you may have a river, for instance. And let's suppose that you have this amount of water into the river. This level of water, sorry. Okay, what happens is that from here you have infiltration again, rain, even here, and then infiltration. So by getting infiltration, what happens is that you have some water stored here, which flows into the river. This is the surface water level, which is also called water table. Okay, so keep in mind that when the surface water level is sloped, it means that there is a flow of water. Of course, what happens if you take a glass and you fill it by water, the water level gets horizontal for obvious reasons that we don't discuss here. On the other hand, if you pour water from the glass, basically you see that the water surface gets sloped in order to originate the flow. And the reason is that some of the potential energy needs to be converted to kinetic energy, and therefore you have the water level that decreases. So basically, again, keep in mind when you see that a water surface, a free water surface, and this is an underground water surface, but it's connected with the atmosphere. So it's a free water surface that is sloped. It means that you have the flow in the direction of the slope. I say this because sometimes it happens that students, if they depict a cross-section of the river, basically then they draw the water table in this way and they say flow here towards the river, which is not correct. If you have the water table that is sloped outbound of the river, it means that the river is feeding the aquifer, not the opposite. Okay. So in this case you have infiltration with a superficial aquifer that drains into the river. And again, this is a rocky layer. So what happens to the infiltration here? It happens that maybe that a surface, a free surface of flow is established through infiltration. And then when the water gets against the rocky layer, the flows goes down along the rocky layer. But of course, it is not anymore the aquifer here at direct contact with the atmosphere. So what happens here? It happens that this aquifer above the rocky layer is unconfined. It means that there is nothing else than atmosphere above. This aquifer below the rocky layer is confined by the rocky layer. What happens here? It happens that if you dig a well, what happens is that water from the unconfined aquifer goes up to the level that is established upstream. So it means that water pours naturally from the well without need of pumping it. Because a confined aquifer means that you have a pressure of water against the rocky layer. If you dig a well, you get what is called, in Italian it's pozzo artesiano, I think in English is artesian, which means that you get water out of the well without need to pump it. This is how aquifer work. In any case, by digging a well, you can monitor the level of superficial, unconfined, and confined aquifers. So, to make a long story short, what is the way that we have to monitor an underground water body in a similar way as we monitor rivers? The way is to dig a well and look at the water level. Keep in mind that you don't need to really dig a big hole. You don't need to dig a well. It's just sufficient that you dig a small hole and observe the water level. And this small hole is called piezometer. So through a piezometer, which is nothing else than a very small well, you can gauge underground aquifers. Okay, I was looking for a picture of a piezometer, but we can look at it tomorrow. And what we do, essentially, is, when we exploit groundwater, to move forward with a trial and error procedure. We take some water from wells, and then we monitor what happens to the water level in the well, and maybe in surrounding piezometers. And we make experiments. Experiment is overpumping, for instance. We take a lot of water from the well, we lower the water level into the well, and then we stop. And we take note of how long it takes to re-establish the original water level. And this gives an estimate of permeability. Of course, if the aquifer is highly permeable, if it has a good recharge, it gets back very quickly. If the recharge is low, it takes a long time. This is one possibility. And we move forward with a trial and error procedure. Of course, there are concerns, because a trial and error means that you may make some errors. So, while you are exploiting water, it may happen that without realizing it, you overexploit groundwater. And if the groundwater is very old, typically as you get deeper into the ground, you get water that is cleaner, is high quality in general, but because it's getting older and older. Why is very deep underground water higher quality? Because it got filtered along a very long path through rocks, soils, etc., which means that it may be very old groundwater. It sometimes happens that we dig wells and we get water and we realize that it's 1,000 years old. It rained 1,000 years ago. And the way we can detect it is by studying the isotopes of groundwater, like C14 or etc. And therefore, by studying isotopes, we can relate the composition, the isotopes of water with the isotopes of the atmosphere. So in many cases, we find water that is 1 week old because we have observation of isotopes in the atmosphere, and by observing isotopes in groundwater, we can relate them. In some cases, we get isotopes that we know were present like 1,000 years ago, and therefore, or isotopes that decayed in a way that prove that water rained 1,000 years ago. In this situation, we have to be very careful, because even if for some reason we see that the aquifer quickly recharges, it may quickly recharge because there might be quite close some reservoirs of water that is still rained 1,000 years ago, which are depleting, which are getting exhausted, and we don't realize it because we are not monitoring the aquifer that is recharging. We are monitoring the aquifer that we are overexploiting. So there are some people who are concerned because they say, if the water is 1,000 years old, it means that it took 1,000 years to get here. And therefore, if we get it, then sooner or later it will get exhausted, depleted, and then we will have to wait 1,000 years to get to the original situation. So, besides looking at the piezometers and water level in wells, we also try to look at isotopes. This is what is about inductive assessment of groundwater. And for more information, basically this is what I said. For more information, you can look at the web pages. Okay, that's it. And tomorrow we will start with deductive assessment. Okay, thank you.